Okay, we will start a new chapter which is called SHM. Molecular definition, the full form molecular, simple harmonic motion. Okay, lesson name only they are saying simple, right? So lesson is simple only. Attention name, simple harmonic motion. Oh. So to understand simple harmonic motion, we have to know basic thing is periodic motion. Periodic motion means periodic motion. Matlab it repeats the interval in specific time, right? Because motion of an object that regularly returns to the given position in a fixed intervals of time. In fixed interval of time, it again come back to the original position. This is called periodic motion. It goes on happening this one. Okay, example we can take like motion of a moon around the earth in a fixed intervals of time, it will come, right? And motion of a piston in center, the motion of a simple pendulum. So these all are example of periodic motion. Because periodic means it returns to a given position after a fixed intervals of time. Okay. Now, next one we have to go for the examples of periodic motion because spring and the block, very important case. We are using this one majorly in oscillator motion, spring and block. Because spring, these all are periodic motion. These all are periodic motion. Yes, these all are periodic motion. Okay. Now next one we have to go for oscillatory motion. Oscillatory motion means the body is moving to and fro, right? An oscillatory is a special type of periodic motion in which a particle moves to and fro about a fixed point called mean position of a particle, and this is called oscillatory motion. About the mean position, it will oscillate to and fro. Such motion is called oscillatory motion. And in mean position, it is oscillating to and fro, to and fro. The periodic motion. This is also periodic motion. This is also periodic motion. About its mean position, about it is rotating. This is moving to and fro. Now tell me, sentence mein right or wrong? All periodic motions are oscillatory. True or false?
False.
False. All oscillatory motions are periodic.
True.
Yes. Okay. These are the examples. All oscillatory motions are periodic, but all periodic motions are not oscillatory. Okay. Now, oscillation. Now I want to write about the force equation. I want to write. Okay, for oscillatory, not simple harmonic motion, for oscillatory motion. So आपको oscillatory motion में आपको formula, general formula is F equal to minus k x power n. This is general equation. Okay, minus k x power n, where n should be odd numbers 1, 3, 5, 7. Why? Because you have to remember always this one. This is a spring and the block. Okay, you tell me when the block, this is a mean position, right? Mean position. When the block moves right side, the force acting is in left side. Displacement is right side, force is left side. Of course. Similarly, if you compress, displacement is left side, force is mean position ke taraf hai. Opposite direction. That's why minus. Minus is force and displacement should be in opposite direction. That will be satisfied only when n is odd. That's why this is a F equal to minus k x power n is a basic formula for oscillatory motion. Non-oscillatory motion means even number 2, 4, 6. Okay. So oscillatory motion के बाद then we are going for the simple harmonic motion. Basic things understand also, less questions will be easy. They are doing this chapter only, or they are doing some other chapter?
So this only. This only.
Yeah.
Yeah, so done.
Yeah. Now we'll go for the simple harmonic motion. Short form है SHM बोलते हैं. SHM. Okay, what is simple harmonic motion? First थोड़ा definition, बड़ा definition understand करो. It is a type of oscillatory motion in which a particle moves along a straight line. Very important. The motion should be a straight line motion. Then only it is called simple harmonic motion. First of all, okay, straight line motion नहीं है तो simple harmonic motion नहीं है. Okay. Under the influence of restoring force should act that is directly proportional to the displacement from the mean position, acts in the opposite direction. So देखो आप स्प्रिंग एंड ब्लॉक को इधर उधर घुमाए तो भी ऑलवेज देखो रिस्टोरिंग फोर्स इज एक्टिंग टुवर्ड्स द मेन पोजीशन ओनली. डिस्प्लेसमेंट ऑफ द पार्टिकल राइट साइड लेफ्ट साइड जा रहे हैं, बट रिस्टोरिंग फोर्स इज एक्टिंग ऑलवेज टुवर्ड्स द मेन पोजीशन. दिस सच टाइप ऑफ मोशन इज नथिंग बट सिंपल हार्मोनिक मोशन. ऑसिलेटरी मोशन में टू एंड फ्रो जाएगा, बट इट इज अ स्ट्रेट लाइन मोशन. दैट्स व्हाई आपको पीरियोडिक दिस इज 8 मार्क्स चैप्टर राइट. आपको आईपी में दिस इज 8 मार्क्स चैप्टर. ऑसिलेटरी मोशन में सिंपल पेंडुलम टाइम पीरियड का डेरिवेशन विल बी देयर. दैट इज ओनली 8 मार्क्स एग्जाम में आने वाला है. ओके, द टाइम पीरियड डेफिनेशन, टाइम पीरियड डेरिवेशन करने समय वी विल अज्यूम इट इज अ स्मॉल ऑसिलेशन. व्हाई? इन स्मॉल ऑसिलेशन में द पीरियोडिक इट इज अ स्ट्रेट लाइन मोशन. वी कैन ट्रीट दैट एज स्ट्रेट लाइन मोशन. Okay, then only we can treat that as a simple harmonic motion, and we are doing certain assumptions. But larger amplitude में ऐसा घूमने वाला, it is not a simple harmonic motion. It is oscillating motion, but not a simple harmonic motion. Simple harmonic motion में always the particle should move in a straight path. Okay, and इसका generally since simple harmonic motion, simple का equation में n value should be 1 in force equation में. So the formula for simple harmonic motion अभी क्या है? F equal to minus kx is a formula. So first formula we have to learn F equal to minus kx is a simple harmonic motion. K is force constant and F is restoring force. So simple harmonic motion is a straight line motion.
1 second. Yeah, so done.
So ये diagram आपको याद रखो for numericals के लिए. Now how we are writing we wrote force in terms of displacement, right? Similarly, I want to write acceleration in terms of displacement, velocity in terms of displacement. If you done that one, then you can do numericals. Okay. Okay. Now इसका ग्राफ कैसा रहेगा? कल में ग्राफ force versus displacement का ग्राफ कैसा रहेगा?
It will be a straight line.
ऐसा?
Yeah.
मानो you कल में बेटा ना?
I think it's correct.
But wrong. देखो, if you see carefully, force positive है, displacement is also positive. But force and displacement will be in opposite direction. Okay, this is not satisfying. Even though it is a linear equation, it's not satisfying. So the coordinate will be in the second and fourth quadrant. Right. देखो, if I draw force versus displacement graph, देखो force is positive, displacement is negative. Here also, force is negative, displacement is positive. Opposite direction में रहने का. So the graph of force displacement graph is in the second and fourth quadrant. Now we have to know some terminologies based on this motion only. ये आपको याद रखना है. Spring and block का याद रखो always. मीन पोजीशन के उस तरफ जाएगा, इस तरफ जाएगा. This only come. If you know this diagram, so many questions you can able to answer. Okay.
Run.
Now some terminologies better know. First one is amplitude. Amplitude. Okay. Amplitude क्या है? The maximum displacement of the particle executing SHM from the mean position is called as amplitude. It is denoted by A. So always remember, this is the mean position. These are extreme positions. Extreme position means the particle को इतना तक खींचा, बस उतना ही, उससे ज्यादा नहीं आएगा, उतना तक खींचा. Okay, and leave किया तो it will oscillate, right? This is nothing but this is x equal 0. This is called mean position. Mean position. Mean position में displacement is 0. Okay, and here x equal to plus a, and here x equal to minus a. This is called amplitude. A is the amplitude. कितना maximum displacement from the mean position किया है, that is called amplitude. And compress कितना compress करेगा, that is also amplitude. So the SHM will operate between plus a and minus a only. Plus a and minus a. Okay, and these are called extreme positions. Extreme position. Mean position, extreme position. Next one.
One second. Yes, sir.
Next one is time period. Time period is time taken by the particle to complete one oscillation is called time period. One oscillation. Tell me, one oscillation means from, if I start from mean position, tell me what is the meaning of one oscillation? If the particle is starting from the mean position, what is
The mean position going to the extreme position and coming back to the mean position.
From
Right.
A to 0.
This is x equal to minus a, this is x equal to plus a. Tell me, आप बोलो, प्रणव, the mean position the particle is started.
From 0 to plus A to minus A, and minus A again to B.
That is complete oscillator. That one time period. It is not from mean to extreme to mean नहीं है. One time period is from here to here, again coming here, again coming, going back, again coming back. This is called time period. Man understood? ऐसा नहीं कि only here time period नहीं है. इधर से जाके पीछे जाके आने का. This is called time period. And now if the total time period is t, तो देखो इधर से इधर तक t/4 लगेगा. And again पीछे आने के बाद also t/4, and again t/4, and again t/4. So 4 और t/4 ऐड किया तो आपको टाइम पीरियड इज t. So simple harmonic motion का टाइम पीरियड इज t. It is divided into 4 equal intervals always. Okay, हम लोग ऐसा छोड़ देगा ना, ऐसा ऑफसेट इन स्ट्रेट लाइन मोशन, राइट, इन t/4 में जाएगा. So this is called time period.
Yes, sir.
Yeah. Next one is frequency. Frequency is the number of oscillations completed in 1 second. 1 second में कितना oscillation complete करेगा? And you know frequency and time period का form relationship क्या है? F equal to 1/t. And we can estimate the frequencies, second inverse or hertz, we know already. And angular frequency we represent as omega. And angular frequency का formula है 2πf or 2π/t. The rate at which object completes oscillation. कितना rate में, कितना fast में the object will be completed. That is called angular frequency. 2πf से depend करने वाला है. 2π/t is a formula. ये बहुत इंपॉर्टेंट फॉर्मूला है इन ऑसिलेशन चैप्टर में. मेजरली दे विल आस्क टाइम पीरियड ऑफ द सिस्टम. टाइम पीरियड from this, what is time period is equal to? Time period is equal to 2 pi by omega. So whenever they ask the time period, पहले omega find करो, then substitute in the formula to get time period. Always in all oscillation chapter में they'll ask time period only majorly. Time period is 2 pi by omega. Omega find करो, then we can substitute. These are the basic terminologies in SHM. Yeah.
That's done.
Yeah. Next. SIOT is radians per second. Radians per second is the angular frequency. Okay. Now I want to find the expression force in terms of displacement, acceleration in terms of displacement, velocity in terms of displacement.
Single differentiation gives velocity, double differentiation gives.
नहीं कुछ नहीं. Single differentiation नहीं है, double differentiation नहीं है. Why? Because it is not in terms of time. In terms of displacement we are talking about. Okay, in terms of time में that all things will happen. Differentiation. Okay. चलो. Now restoring force का already we found. Tell me force in terms of displacement क्या है equation? F equal to minus kx is a formula. Force in terms of displacement आ गया है. And where k is force constant and k का formula is m omega square. Very important. M omega square is a formula for k. And m is what? Mass of the particle. Mass of the particle. So force in terms of displacement आ गया है first expression. If you get force in terms of displacement, we can find acceleration in terms of displacement also. Computer, m omega square. M is the mass of the particle. And x is what? Always a displacement from the mean position. That is very important. X is always you have to calculate displacement from the mean position.
That's done.
Mean position में displacement कितना है? Tell me. Mean position में displacement is how much? How much?
A.
No. Mean position
by 2.
0. Mean position में 0.
Oh, displacement. Yeah, my bad.
Displacement from the mean position always you have to calculate. Okay. Now, next one is acceleration. You know acceleration formula already. F equal to minute. A equal to F by M. And F equal to minus kx in SHM by M. And k का m omega square x by m. So m cancel. A is equal to minus omega square x. देखो acceleration in terms of displacement भी आ गया है. A equal to minus omega square x. Now in this SHM में here displacement to 0 at the main position, and here displacement is plus a, and here displacement is minus a. Okay. When the particle, I will bring the particle here and leave. Okay. You tell me acceleration is maximum at which position? Mean position or extreme position? Acceleration is maximum at which position?
Extreme.
Extreme. Why?
So because displacement will be A.
Extreme position. Therefore, it is depending on displacement, right? More the displacement from the main position, the acceleration is maximum. And force is also maximum, right? So acceleration is maximum at extreme position. So what is the maximum acceleration? Formula will be x equal to a लगाओ mod लगाओ minus निकालो omega square a is a formula for maximum acceleration. And maximum acceleration किधर रहेगा? Extreme position. And mean position में acceleration displacement is 0. Acceleration will be 0. So minimum acceleration is 0 at mean position. So particle when oscillating about the mean position and extreme positions, acceleration will be maximum at extreme position only. And maximum acceleration का formula है omega square a. Okay. Now इसका भी ग्राफ कैसा रहेगा? एक्सेलरेशन का ग्राफ कैसा रहेगा? इज ऑल्सो देखो प्रोपोर्शनल टू 1, मतलब स्ट्रेट लाइन आएगा एंड फोर्स किस तरफ पे एक्सेलरेशन भी वही डायरेक्शन में रहेगा, सेम डायरेक्शन। अब बेटा देखो यही आएगा सेकंड एंड फोर्थ क्वाड्रेंट में एक्सेलरेशन वर्सेस डिस्प्लेसमेंट एंड स्लोप इज व्हाट y equal to mx से if you equate slope is omega square. Okay, so you got second formula also, acceleration in terms of displacement. Okay, so now we'll go for the velocity. Velocity in terms of displacement. So v is equal to formula याद है? Tell me, velocity in terms of displacement formula क्या है?
Omega under root a square minus x square.
Plus or minus omega under root a square minus x square is a formula for velocity in terms of displacement in SHM. So third formula भी आ गया. Now tell me, velocity is maximum at where? Extreme position or mean position? Velocity is maximum at where?
Mean position.
Because मैं पार्टिकल के ऐसा लेके इधर स्टॉप किया ना, इधर वेलोसिटी 0. इफ आई लीव जूम बोल के आएगा, ना पास में आएगा. सो वेलोसिटी इज मैक्सिमम एट मीन पोजीशन एंड वेलोसिटी विल बी 0 एट एक्सट्रीम पोजीशन. सो मैक्सिमम वेलोसिटी फॉर्मूला, मैक्सिमम वेलोसिटी मैग्नीट्यूड लगा रहा हूं, प्लस से आएगा x के जगह में 0 लगाने का, राइट? मीन पोजीशन में 0, सो a स्क्वायर रूट रहेगा ओमेगा and this is at mean position. Mean position. Okay. Now इसका ग्राफ कैसा रहेगा? चल में वेलोसिटी इन टर्म्स ऑफ डिस्प्लेसमेंट का ग्राफ कैसा रहेगा? Which shape आएगा?
So it will be 0 at extremes and maximum at mean.
Okay, which shape that is? Straight line. Okay.
I think a parabola.
Parabola. Parabola is y equal proportional to x square रहने का, right? Degree 2 रहने का. So इधर degree 2.
So will it be the ellipse? No, I don't think so.
Yes, ellipse is answer. Okay, ellipse. Why? Because देखो, if you multiply and divide with omega square a square divide किया तो आपको ये फॉर्मूला भी मिलेगा. That means ये आपको ellipse का इक्वेशन मालूम है ना? x square by a square plus y square by b square is equal to 1, right? So ये फॉर्मेट में है. So that's why it is a ellipse shape. Velocity in terms of displacement is ellipse shape. Okay, now formulas एक बार बैठ करो class. Force in terms of displacement, velocity in terms of displacement, acceleration in terms of displacement. Because वो पूछेगा पार्टिकल at a/2 में कितना स्पीड है, at a/3 में कितना स्पीड है, वो पूछेगा किधर, मतलब डिस्प्लेसमेंट का इक्वेशन यूज करना ही पड़ेगा. टाइम का इक्वेशन नहीं है, टाइम के बाद में. ओके, बैठ करो, we'll do numericals.
Sir, A max is omega square A, right?
ए मैक्सिस फॉर्मूला क्या है? नॉर्मली ए का फॉर्मूला क्या है? माइनस ओमेगा स्क्वायर एक्स, राइट? एक्स के जगह में ये
Yeah.
लगाओ तो ओमेगा स्क्वायर है.
Yeah, sir.
Tell me all formulas.
So restoring force is F is equals to minus kx, where k is m omega square. And then acceleration is minus omega minus omega square x. So A max is omega square A, and A minimum is 0.
Okay. Velocity. V.
Velocity is plus or minus omega into root of a square minus x square. And then in V max it's omega square A, and then V minimum is 0.
Okay. And V max is mean position में this maximum, right?
Maximum.
Yes. चलो numericals करेंगे. So always you have to remember the straight line motion, spring and block. You have to remember all questions you can solve. So numericals करेंगे. करो. Have your options. Because particle is executing SHM with an amplitude is given. When the particle is 4 centimeters from the main position, the magnitude of velocity is equal to its acceleration. In this condition, it's telling to find the time period in seconds. Time period. So magnitude of velocity is equal to magnitude of acceleration. In that case, he's saying to find time period. Time period तो मालूम है आपको, always formula is 2 pi
8 pi by 2.
8 pi by 3.
Yeah.
So one second.
देखो. अगर ओमेगा फाइंड कर सकता है तो देन सब्स्टिट्यूट करो, आ जाएगा.
Sir, velocity will be omega A only, right? No, it will be, sir, if I do omega into root of A square, oh my god, it's 3 omega. Wait, sir, I did a calculation mistake. Sir, I'm getting acceleration as minus omega square x, right? So I have to take it as positive only.
They are not maximum. This is normal one. Magnitude wise and all.
Yeah, acceleration is omega square x, right?
So x is how much?
4.
A is how much?
So you'll get 4 omega square is equals to omega 3 omega.
So omega is how much from this?
So you'll get omega is 3 by 4.
No, substitute time period.
So is equals to 2 pi by t. Yeah, 8 by 3, my bad.
8 results.
Yeah, 8 pi by 3.
Yes. The JEE Mains questions करो. The maximum velocity of the particle executing a system with an amplitude is 7 millimeters is 4.4 meters per second. Okay, the period of oscillation, time period itself. The maximum velocity is given, amplitude also given, time period.
The period of oscillation means time period only, right?
Yes, yes, correct. Time period.
So I got 0.01.
देखना.
Yeah, 0.01.
Yes, because maximum velocity का formula क्या है?
Omega है.
Omega. So omega, omega find करके t equal to pi by omega. Correct.
Yeah.
So particle is making SHM with the x-axis at a distance x1 and x2 from the mean position. The velocities are given. मतलब mean position से x1 distance में velocity v1 है. Mean position से x2 distance में velocity v2. The time period of oscillation in terms of x1, x2, v1, v2 are known. Answer. In terms of x1, x2, v1, v2 में चाहिए time period.
So shouldn't we like take two separate cases and solve like where v1 square is equals to omega square?
Normally x1 दिया है ना, x1 v1. So what is the relationship? क्या है? v1 is how much? Omega under root a square minus x1 square. Because इसका SHM का amplitude is same, omega is same. Similar velocity कितना? v2 is omega under root a square minus x2 square. The velocity is at that position x1, x2. इसको solve करके you have to find omega and then from that you can find time period. So squaring of
Sir, I got answer as 2 pi under root x1 square minus x2 square by v2 square minus v1 square.
So yeah, scroll करना. So squaring of motion क्या था? v1 square is equal to omega square into a square minus x1 square. Similarly, v2 square is equal to omega square into a square minus x2 square. Okay. So if you know subtract curve, subtract किया तो we'll get omega. कितना है प्रणव? V1 square.
Sir, only we want in terms of x.
In terms of x and v में चाहिए. So subtract किया तो क्या होगा? So omega square a square cancel हो जाएगा. Minus omega square x square. Minus omega square x1 square and v2 square minus of minus plus हो जाएगा. Plus omega square x2 square. So omega square omega is equal to कितना होगा? इधर x2 square minus x1 square आएगा. So v1 square minus v2 square by x2
So what
square.
happened to the A? Oh, never mind.
Okay. So therefore time period is 2 pi by omega. So therefore 2 pi under root नीचे लगाए तो उल्टा हो जाएगा ना, x2 square minus x1 square by v1 square minus v2 square.
So I got x1 square minus x2 square by v2 square.
वही उसी को minus you can remember this like a formula, standard formula है, very important. Okay, at different position में अगर velocities देगा, you have to remember directly time period पूछे तो under root x2 square minus x1 square by v1 square minus v2 square. A positive value आएगा because under root positive should be there. Okay, don't get confused x2 minus x1 x1 बड़ा मैंने छोटे करने का बस. x2 square minus x1 square by v1 square minus v2 square. This is a formula you have to remember for this type of solution. Okay, next. Michael. So numerical based answer. Question: the position, velocity, and acceleration of executing SHM have magnitude 4 meters. Position, velocity, and acceleration. Everything is given to you. Find the amplitude of the motion. If the amplitude of the motion is root x, find x.
So one second. So I take omega's positive value only, right?
Yeah, positive value like all this.
Velocity is 2. So I got 17.
So I'm getting in fractions.
No, 17 is also. The position, velocity, acceleration is given, right? So
We'll get omega's 2. Omega's 2.
A is equal to omega square x. So So A value is how much? 16. No? 16 is equal to omega square x is 4. So omega is equal to, the velocity of velocity is equal to omega under root a square minus x. So from this amplitude find karo. B मालूम B is how much? 2. 2 by omega is 2. Squaring of both sides will be 1 whole square is 1 only. A square minus x square. X के जगह में again substitute 4. 1 is equal to a square minus x square. X square is how much? 16. So minus 16 is under 17. So x is 17 is answer. Yeah.
Yes, sir.
So these are the equations in terms of displacement. Okay. So it will. The distance of the particle from the main position when speed becomes 5 centimeters per second. जब speed इतना है कितना position में x value रखते.
So omega same for both, right?
Yeah.
Well,
So I got
basically,
two.
that main position velocity is 10 means Vmax is 10, right?
Yes, mean position में always maximum velocity.
Sir, I am getting 2.
I'm getting in roots.
रूट में आएगा. Not 2.
I got root 12.
Yes, correct. Root 12 is answer. Amplitude is given at the mean position, the velocity of the मतलब V max is 10 equal. V max is equal to omega A is equal
Yeah,
to 10.
sir, I got it.
Got it?
Okay.
Okay, next. Distance x value is answer. Formula है क्या? No. Differential equation for SHM. Differential form में sometimes they'll give directly the differential form में also it will be useful. From where we'll get this one, right? A is equal to minus omega square x is a equation we know, right? A in terms of displacement क्या है? 2 times differentiation क्या था? You'll get the acceleration, right? So I can write like this: d square x by dt square. Acceleration की जगह में, right? 2 times differentiation of displacement gives acceleration. ये माइनस को इधर लेके आए तो प्लस आएगा, प्लस ओमेगा स्क्वायर एक्स इज इक्वल टू 0. दिस इज द डिफरेंशियल फॉर्म ऑफ SHM. डिफरेंशियल फॉर्म थोड़ा हेल्पफुल होगा बिकॉज ही कैन कंपेयर लाइक दिस d square x by dt square plus 5 omega square is equal to 0. Okay, or you can write like this. They can be like this: 5x is equal to 0. Okay. Now we'll tell to find time period of this SHM. What is the time period at that time?
2 pi by root 5.
2 pi by root 5. Why? We compare omega square is 5. Omega is equal to root 5 and t is equal to 2 pi by omega. 2 pi by root 5. So आपको ऐसा छोटे-छोटे प्रॉब्लम्स करने के लिए डिफरेंशियल इक्वेशन यूज करोगे. So this acceleration only in terms of differential form we are writing. Covered? Chalo. Now equation of SHM in terms of time period, in terms of time. Now अभी तक in terms of displacement we learned. Now in terms of time we are learning. Okay. So what is the general differential form? D square x by dt square plus omega square x is equal to 0. This is a differential form, right? इसको आपको इंजीनियरिंग में you'll get how to solve differential equation बोल के आपको इंजीनियरिंग में आएगा by using Laplace ट्रांसफॉर्म वगैरह करके अब जरूरत नहीं इसको सॉल्व करने से you'll get equation x is equal to a sin omega t plus phi. इसको सॉल्व करने के बाद we'll get this equation. This is a general, देखो displacement in terms of time में आ गया first equation we got displacement in terms of time. And what is omega t plus phi? इसको क्या बोलते हैं? We call as phase. याद रखो साइन का ब्रैकेट में अंदर जो भी है उसको phase बोलते हैं. And a it is amplitude and x is already displacement from mean position. From mean position. Okay. ये phi को क्या बोलते हैं? Initial phase. Initial phase. Phase बोलते तो किधर स्टार्ट हुआ पार्टिकल? मेन पोजीशन में या एक्सट्रीम पोजीशन में या और बिटवीन में है. This is called phase. Initial phase, wherever it started, that is called initial phase. At time t equals 0. This is we are calculating time t equals 0. पार्टिकल इनिशियली किधर है? That is called phase. phi के जगह में वो लगाना पड़ेगा. Now इसको आपको कैसे सॉल्व करेंगे? देखो एक एक का इक्वेशन थोड़ा समझो. When the particle is doing SHM, it can start from the main position and going right side, or it can start from the extreme position and moving left side, or left extreme में जाके right side जाएगा. किधर भी हो सकता है particle. So based on that उसका इक्वेशन बनाना पड़ेगा. So इसका इक्वेशन कैसा आएगा? We will see. So क्या देखो अंडरस्टैंड करो. सपोज मान लो x equal to a sin omega t plus phi. On the video now. So the particle मान लो it is starting from the main position. See always have the sin always starting from the main position. Cos always starting from the extreme positions. Okay. Now मान लो the particle is going to the right side. Particle is starting from the main position and going right side. तो उसका इक्वेशन बनाने का from this only always पार्टिकल किधर भी स्टार्ट होने दो पहले ये इक्वेशन डालेगा पहले. ओके. और a sin omega t plus phi. Okay. Tell me here mean position से स्टार्ट हुआ. mean position में x is how much? X is 0. Substitute x equal to 0 equal to sin omega t plus phi. So phi initially मान लो time t को 0 है. time t को 0 है. t को 0 लगाओ कितना होगा sin phi.
So you get phi as 0.
Now phi वैल्यू कितना है?
0.
No, 0 भी हो सकता है, phi भी हो सकता है ना, right? 0 sin 180 also 0, right? So दोनों में से which is right? कैसे पता चलेगा? Which is right? Who is a deciding factor for direction के लिए? Which parameter is deciding factor for the direction of motion? क्या है? Direction of motion decided by velocity. Velocity decides. So velocity find करके we will decide whether 0 ना पाएगा. Okay. See एक derivation कर रहे हैं उसके बाद we will generalize. We will by heart how to write the formula. Okay. So understand करो. Now velocity we are trying to find. So v is equal to dx by dt. Differentiate करो इसका. क्या आएगा इसका जनरल इक्वेशन को डिफरेंशिएट किया तो a sin omega t plus phi का into omega, right? So इधर क्या आएगा? a omega a and sin का cos है डिफरेंशिएशन omega t plus phi. याद है ना चेन रूल यूज करके we are trying to find omega t का डिफरेंशिएशन किया तो अगेन omega आएगा. That's why omega. Okay. Now tell me at t equals 0 the velocity is positive or negative? Tell me. At t equals 0 the particle is moving to the right side. Right side means is positive, right? Velocity is positive. Okay. Now velocity पॉजिटिव होने के लिए in this में t को 0 सबसे पहले t को 0 I'm putting v is equal to omega a cos phi. Okay. Now velocity पॉजिटिव होने के लिए phi वैल्यू कौन सा लगाए तो आपको पॉजिटिव आ रहा है? 0 ना और pi. Which one? 0. Because cos 180 is minus 1, right? So इधर दो ऑप्शन है आपको 0 and pi. So 0 वाला is right. Okay. Now I'm substituting the general this 0 value in the general equation. तो क्या होगा? X is equal to a sin omega t. This is a generalized equation when the particle is starting from the main position and going right side. आपको solve करने के लिए ऐसे method करना पड़ेगा, but we will learn when the particle is at main position going right side directly we'll get this one. Okay, x equal to a sin omega t. अगर velocity क्या है बोले तो if I got displacement in terms of time, velocity क्या होगा?
a omega cos omega t
In
plus
acceleration कितना होगा?
a omega square.
नहीं, a omega square. No. What is the equation? See,
Just
what is
differentiate.
Oh, omega square a sin omega t plus phi.
नहीं, इसको we got the expression parallelly, right? Now differentiate किया तो velocity आएगा and देखो minus omega. If इसको differentiate किया तो we'll get acceleration. So cos का differentiation is minus, right? So omega square a sin omega. This is double differentiation. ये कैसा आएगा मालूम है? देखो शॉर्टकट देखो. It is nothing but minus omega square x only. देखो x क्या है? X is nothing but a sin omega t. देखो a sin omega t minus omega square. So always ऐसे आएगा कभी भी. A का डायरेक्टली अगेन डोंट नीड ऑफ डूइंग डबल डिफरेंशिएशन माइनस ओमेगा स्क्वायर एक्स ही आएगा. ओके, यू हैव टू अंडरस्टैंड दैट आपको व्हेन द पार्टिकल टेल मी मानो व्हेन द पार्टिकल इज स्टार्टिंग फ्रॉम द मेन पोजीशन एंड गोइंग राइट साइड देन डिस्प्लेसमेंट क्या डालेगा? डिस्प्लेसमेंट इक्वेशन इज
a sin omega t.
omega t directly. Again no need of putting omega t plus phi. If the particle is starting somewhere in between then लगाना पड़ेगा phi लगा देना. Initial phase है ना. Other than that standard one is there now. Okay, done. Okay. Now देखो इसका ग्राफ कैसा रहेगा? देखो a sin omega t. Sin का ग्राफ मालूम है ना? It's starting from the main position and going like this. This is the sin graph.
Can I go back once? Yeah, sir.
Okay. This is a sine graph. When you differentiated, you got cos terms, right? Cos always start from 0, right? Either above or below. Here plus है तो above आएगा, plus है ना तो starting में above आएगा, minus है तो below आएगा. Okay, since plus is there, above से आएगा. Okay, cos का ग्राफ. And you know I can write in terms of sine में so that I can compare with phase. Okay, sine में I can write as sin omega t plus pi by 2. So what is the phase difference? कितना होगा? इन दोनों का phase difference so much. Phase means sin का बाजू में जो भी है वो phase. Sin के बाजू में जो भी है that is phase. Phase difference means this minus this. It is pi by 2. Okay. Similarly, I wrote sin in terms of I can write like this sin omega t plus pi because both are same only. Omega t plus pi. And इन दोनों का phase difference कितना होगा? Pi by 2 only. Pi minus pi by 2 is pi by 2 only. Now tell me what is the phase difference between displacement and acceleration? Displacement pi. Okay.
Yeah.
देखो, and a is minus omega square x. Sin है ना, that's why it's starting from origin. But minus है ना, it is going below. The sin का always starting from the origin and cos का it is starting from either above or below में आएगा. And a omega is the amplitude, right? That's why ऐसा amplitude लगा है. इतना amplitude में offset होगा. Okay. Now we have 4 different types of cases we have. What are the 4 different types of cases? Tell me. When the particle can start at main position going right, main position left, extreme position left, or right, extreme position is right side. So all 4 cases का general equation लिखना आने का. Okay. So the general equation is this one. देखो, first one particle is starting from the right side position. Very important. लिखो x equal to a sin omega t. And when the particle is starting from the main position going left side, that time क्या आएगा? X equal to minus a sin omega t. ये equation are important. Problems नहीं कर पाएंगे दो. ये आगे तो ही आपको कर सकते हैं. If you know this equation, then you can find velocity, then you can find acceleration. If you don't know this equation, you cannot find. Okay. Now, when the particle is starting from the extreme position, that is minus में start हो रहा है ना, so it is minus a cos omega t. When the particle is starting from the right extreme, right में always positive ना, so x equal to a cos omega t. Extreme position में cos आएगा, mean position में sin आएगा. Okay, लिख लो equation. आपको ये डायग्राम ड्रॉ करके ये वाला इक्वेशन, ये डायग्राम ड्रॉ करके ये इक्वेशन, ऐसा डायग्राम ड्रॉ करो. वेरी इंपॉर्टेंट करो. Now they'll ask after 10 seconds में पार्टिकल किधर है, इसमें कितना है, बोलते x वैल्यू फाइंड करने का. And the 10 seconds पूछ रहे हैं ना, that is instantaneous time, t को small t equal to 10 लगाना पड़ेगा. समझ में आ रहा है? So they'll ask at the not in terms of displacement, they'll not ask. They'll ask in terms of time. After 5 seconds, where is the displacement of the particle? After 5 seconds, suppose मान लो, how will you tell me? After 5 seconds, what is the velocity of the particle? How you will tell me? Suppose
So
particle
it
starts
is,
from the
W a cos omega t plus 5.
पहले x का इक्वेशन लिख के then differentiate करना पड़ेगा to get velocity. Okay? क्या बेटा? चलिए.
So can't we just at a point say that if it starts from extreme, then it's cos, and if it starts from mean, it's sin?
But प्लस से है ना माइनस से आपको तो डायग्राम में समझो. ये आगे तो न्यूमेरिकल्स पूरा कर सकते हैं इन टर्म्स ऑफ टाइम में. मेन पोजीशन से राइट साइड गया तो पॉजिटिव, लेफ्ट साइड गया तो नेगेटिव, माइनस से साइन. तो इसका न्यूमेरिकल्स हम लोग नेक्स्ट क्लास में पूरा करने वाला है. मतलब आपको इजी है, इसके बाद आगे